Alright, so this is section 4.3, so we're talking about right triangle trigonometry. So we're going to learn about the 6 trigonometric functions and how they're related to right triangles. Alright, so in this section you'll be able to evaluate trig functions of acute angles, you will be able to use trig identities, and you'll be able to use trig functions in applications. Alright, so the first thing we're going to talk about is trigonometric functions of acute angles. So if you remember, an acute angle is an angle that measures less than 90 degrees, or, I'll do this in green, less than pi over 2 radians. Alright, so a right angle measures exactly 90 degrees, or exactly pi over 2 if we're using radians, and the sum of the angles of a triangle is 180 degrees. So if you take a triangle like this and add up all of the interior angles, you should get 180 degrees, which is also pi. Okay, so if we know two sides of a right triangle, we can use the Pythagorean theorem to find the third side, so we're familiar with doing this. So for example, let's say this is side A, side B, and side C. The Pythagorean theorem says that a squared plus b squared equals c squared. All right, and then we also talk about the sides of our triangle using names in relation to the angle. So if we're talking about a particular angle inside of our triangle, so let's say we talk about this angle theta, we can talk about the side lengths in relation to this angle, right? So this would be opposite of our angle, so this is the opposite side of our triangle. Right next to it is the adjacent side of our triangle, so it's adjacent to our angle. And then, of course, the hypotenuse will be the hypotenuse. All right, so remember the way that we label these sides. We're going to use these to define our 6 trig functions. All right, so in our class, we're going to be talking about 6 trig functions, and we can use right triangles to define them. So if we're talking about a particular angle inside of our triangle, we can talk about sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. These are our 6 trig functions. All right, and so the way that these are pronounced, this one is sine, this one is cosine, this is tangent, this one is cosecant, this one is secant, and then finally cotangent. So you can see some are kind of named after the others. They are related. They're all related actually. All right, and so the way we determine, these are all functions. All right, so the input of our function is theta. So theta is like our x value. So it's what we put into our function. And theta is one of the interior angles here. Okay, so the way we define our trig functions using a right triangle is that sine is the opposite side over the hypotenuse. All right, and then cosine is the adjacent side over the hypotenuse. Tangent is the opposite side over the adjacent side. All right, so these are the really important ones. These are the main 3. And then the other 3 are just reciprocals of the first 3. All right, so if you flip sine theta, you'll get cosecant theta, which is hypotenuse over opposite. If you flip cosine, you'll get secant theta. And if you flip tangent theta, you'll get cotangent theta. All right, so let's use these and what we know about right triangles to answer the next question. So number 1 says, find the 6 trigonometric functions of theta in the triangle below. So this is our angle theta. It's this interior angle of our triangle. We have 2 of the side lengths, and we want to find all 6 of our trig functions. So remember, to find sine theta, we need the opposite side over the hypotenuse. So the opposite of our angle over the hypotenuse, but we actually don't know it. So that means we need to figure out, okay, what is this hypotenuse or C value going to be? How do we figure it out? We can just use the Pythagorean. All right, so we'll have 5 squared plus 12 squared equals C squared. 25 plus 144 is C squared, which is 169 equals C squared. All right, and then to solve for C, we need to take the square root. This time, do we care about our square root being positive or negative? So get C is 13. We actually only want the positive because this is representing a length or a distance, and those will always be positive numbers. So we don't have to worry about the plus or minus in this case because we're talking about distance or length. So the length of this side is going to be 13. And so now we have everything we need to find our 6 trig functions. So again, sine theta is the opposite side divided by the hypotenuse. Okay. Then we can move on to cosine, which is the adjacent side divided by the hypotenuse. Adjacent is 12. So cosine theta is 12 over 13. And then tangent theta is opposite over adjacent. So we need our opposite side, which is 5, over the adjacent side, which is 12. So tangent theta is 5 over 12. All right, and then I pointed out before, the other 3 trig functions are just reciprocal, so you flip the previous 3. So once you know the first 3, you know the last 3. So that means cosecant theta is going to be 13 over 5. Secant theta is going to be 13 over 12. And then tangent theta is 12 over 5. All right, let's look at a special triangle. All right, so number 2, it says find the sine, cosine, and tangent of 45 degrees using the triangle below. So these next 2 triangles are going to be special to us, so I'll point those out later. This is actually a square root. Didn't finish all the way. Okay, so we want to find sine of 45 degrees. All right, so this is a right triangle where this interior is 45 degrees. This is 90, which means this one is always also going to be 45 degrees. Okay, let's find sine. Remember, here's our angle, and our side lengths are based off the angle that we care about. So sine is opposite over hypotenuse. So 1 over square root of 2. And sometimes in your homework or on a quiz or test, it will say to rationalize your denominator. So sometimes we don't want to have this square root in the denominator. So the way we would rationalize it would be to multiply the top and the bottom by the root that's on the bottom, which square root of 2 over square root of 2 is just 1. So we've just multiplied by 1, so we have not changed the problem. Okay, so when we multiply that out, we'll get square root of 2, and then square root of 2 times square root of 2 is 2. So sine of 45 degrees is root 2 over 2. Okay, let's look at cosine of 45 degrees. That will be adjacent, which is our 1, over hypotenuse. Oh, it's the same thing. That should make sense to us because both of these angles are 45 degrees. So even if we were looking at this one, this would be opposite, this would be adjacent. Same thing, and we can rationalize our denominator for root 2 over 2. So sine and cosine of 45 degrees are the same. And then finally, tangent of 45 degrees. Do we remember what that is? All right, so tangent is opposite over adjacent. So tangent of 45 degrees is 1.